Hello, welcome to my channel. Thank you for subscribing if you've already done so, and please subscribe if you haven't. Okay, so this is my first video uh, for electrical engineering students second year. Of course, I'm talking about the university where I am, the University of Zambia. So this is a question, the first question I'm going to solve in one of the series of like my tutorial videos. Okay, so there are a couple of number of people who requested that no, I should make videos for them. I explain and all that. I hope you're going to like my explanation, of course. Okay, and if you do, please let me know. You can drop your comment in the comment section. Okay, or you can like the video or share with others. Please let others know about this as well. Okay, so you guys, based on your feedback, you are going to motivate me to make more videos. And of course, I don't say don't criticize. Please, if you don't understand, or maybe you feel like what I'm doing is not okay or something, please let me know. Okay, let me know. You can either maybe send me an email, okay, or maybe you can send me a message on WhatsApp. I'm going to drop my details in this video as well, so that you can contact me, okay, and bring up the suggestions. Steve, I want you to make a video on this. Okay, of course I'm talking about the second years at the University of Zambia, and if you are taking the same course somewhere else, okay, in Zambia or maybe other country, whatever, please feel free to email me or maybe send me a message on WhatsApp. Say, okay, I want you to do this topic, and then if I can manage, you just see the video being uploaded. I'll upload the video based on the request that you're going to make. Okay, so without wasting much of your time, people, let us get started. So here's a question. The question reads: for the circuit shown below, obtain V1 and V2. Okay, obtain V1 and V2. So the question just ends like that. They haven't told us that I'll use this method or whatever. So just, okay, obtain V1 and V2. So this question is open. You can apply any method that you think of. Any method that you think that okay, is going to work here, it's the best. Please don't feel shy or whatever. Just apply that method, okay? So in this video, I'm going to use what? Nodal analysis. Okay, I'm going to use it nodal analysis. So nodal analysis, before even you start solving, please, what is it about? You are trying to find the node voltages. Okay, the voltages are the nodes. Remember that the node is what? Okay, simpler terms, a node is more like a point where two branches are connected. Okay, you have a resistor, you have maybe you have a voltage source, of a current source, and then you connect them together at one point, or you connect them using this one wire. That wire now becomes a node. Okay, if all those are emanating from that wire, isn't it? All those elements are connected are emanating from that wire. So what is the properties of a node? Okay, the properties of a node are that what? The voltage at that node is uniform. Okay, is the same throughout. Okay, as long as there's no element in between, then the voltage is the same throughout. So what do I mean here? So if you look at here, okay, if you look at this problem here, we have this is a node, right? Because you have all those elements that you can see connected to it. Oh, you have all those elements that you can see, they are well connected to it. So I have resistor here, resistor here, resistor there, and the current source there. So this requires to be a node. And similarly here, you also have another node there, right? You have how many elements? This element there, this element there, this element there, this element there, they're all connected to that node. So this whole node here is at the same potential. So the voltage V1 is actually the voltage between from here, all these points, right, are all at V1, isn't it? Because I said that the node is at the same potential, right? Even here, this whole portion is at V1, right? Okay, there's nothing in between, isn't it? Okay, even here, this whole thing here is at whatever voltage here it is, right? I'm going to explain what this node is, okay? So that's the property of a node, right? Okay. All right. So now when it comes to node analysis, we have to find what voltage is at that node, okay? What voltage is at that node? All right. So first of all, you have to identify the nodes when you're given a circuit, right? So identify the nodes. Once identify the nodes, assign the reference node. Okay, a reference node is a node whose voltage is what? Zero. It's at zero potential. Okay, so fortunately here the reference node has already been assigned with a symbol, a ground symbol here. This symbol is for ground, right? So it's a ground symbol, meaning that the voltage of this node is what? 0 volts. Okay, and then you have to find the rest of the voltages, isn't it, from other nodes, right? Okay, so once you assign the voltages, okay, you know the nodes, and then you assign them the voltage names. Okay, so this is V1 corresponding node number 1, V2 corresponding node number 2. You do what? Next thing, you apply KCA on that node, right, which is a non-reference node. So these nodes whose voltage is not known are called what? Non-reference nodes. Okay, so you assign KCA. So you assume that the current at that node, you take the node as what? You take it more like a voltage source, so that all the currents are leaving that node. Okay, all the currents are leaving that node. So for example, node number 1, which is a V1 here, you're going to say, okay, I have a current that is moving this direction. I have another current that is moving in that direction, right? Okay, like that. Another current is moving this direction from the same node. Okay, it's more like a source of something, right? It's a source of current, right? Moving that node direction, and another current is going to move in that direction. That for node number 1. Same thing you're going to do to node number 2. So node number 2, you're going to assign that, oh, I also have another current. All the currents actually leaving that node. So of those currents leaving that node, okay, you assign them properly. Okay, leaving that node. Okay. All right, now you're going to give names to these nodes. Okay, you're going sorry, to these currents. Okay, just give them names. Okay, so I'm going to call this one as I1. Okay, I'm going to call this node, this current here as I1, and then I'm going to call this current as I2, and this current as I3, this current as what? I4. Okay, and then here I'm going to call this as I5. I'll call this as I6, this one as I7, this one as I8. Okay, so the next thing now is to apply what? You're going to apply KCL at that node. Remember that KCL says that the sum of the currents at that node must be equal to 0, isn't it? Okay, so apply KCL. So I1 plus I2 plus I3 plus I4 equal to 0. So I1 plus I2 plus I3 plus I4 equal to 0. Okay, for the other node, you do the same thing, right? Okay, so this will be I5 plus I6 plus I7 plus I8 equal to 0. Okay, now you just have two equations here. You see, you have so many unknowns: I1, I2, I3, I4, I5, I6, I7, I8. They are knowns. So what do you do? Okay, because you can't solve these two equations. All those values are not known, right? Okay, so you convert this now to voltages. Okay, remember using Ohm's law, current is simply equal to voltage drop over the resistance where that voltage is dropped, right? So it's a voltage across the resistor over the resistor itself, right? So I1, if you notice very well, I1 is moving from V1 to which node? Okay, all the way to 0, right? It's moving from this node to this 0 volt node, right? So what I'm trying to say here is that I1 is moving all the way, like up to that node, right? So this node here is at a potential V1, or this node is at potential 0, right? So the current will be equal to what? Or the voltage drop across the 10 ohm resistor will be equal to what? The difference between V1 and the other voltage, which is 0 in this case. So I1 will be what? V1 minus 0 divided by what? The resistor, okay? Across that. What about I2? I2 again is moving from V1 to the ground, right? So this will be V1 minus the voltage of the ground, which is 0, divided by 5, plus what is I3? I3 is simply the current, okay, which is 12 amps. As you can see, because this current is already known, okay? This is 12 amp. This is a independent current source, okay? So it's producing that constant current of 12 amps. So I3 will always be 12 amps. Okay, so that is 12 amps. Plus, what is I4? I4 is simply equal to V1 minus V2 because I4 is moving from here to V2, right? So this will be V1 minus V2 divided by 2. So I4, this is an equation. As you can see now, instead of having I1, I2, I3, I4, we only have two unknowns in this equation, V1 and V2, isn't it? So let us simplify this further. So this will be V1 over 10 plus V1 over 5 plus V2 minus, V1 minus V2 divided by 2. So I'm going to take this 12 the other side of the equation. This is negative 12, okay? Now, if you notice, I don't the fractions. So I don't like fractions myself. So what I'm going to do, I'm going to reduce this. Okay, I'll multiply the whole equation by the common denominator or the lowest common multiple of 1, 2, 5, and 10, which is 10 itself. Right? So it's more like I'm multiplying the equation by 10. Okay, so V1 over 10 by 10. So 10 and 10 cancel out, just remain with V1. V1 over 5 by 10. 5 and 10, that's 2. So we're going to have 2V1 plus V1 minus V2 over 2 times 10. So 2 into 10, that is 5. So this is 5 by V1 minus V2. And this is equal to negative 12 by 10, that is negative 120. Okay, so let us simplify this. If you remove the brackets, we have V1 plus 2V1 plus 5V1 minus 5V2 equal to negative 120. We add like terms, we have 3V1. Oh, so this is 5, actually, V1. So we're going to have 8V1, right? So we have 8V1 plus or minus actually 5V2 there equal to negative 120, right? So this is our first equation. Okay, so that is our first equation. All right, let me get rid of this now since we are done with that. I'm going to delete this so that I can also write the equation for the second one, right? Okay. Now for the second node. Okay, for the second node, it's I5 plus I6 plus I7, right? All right. So let's see what is happening here. I5. What is I5? So I5 is the current through the 4 ohm resistor. So this current comes from V2 to the ground, right? So I5 will be V2 minus the ground voltage is 0. And then divided by the resistor across it is 4, right? Plus, what is I6? Okay. If you notice here, I6 is in the opposite direction as I3. So okay, say I6 is in the opposite direction as what? I3, which is negative I3, right? Because they're opposing each other. It's opposing this 12 amp. Okay, isn't it? It's opposing this 12 amps, right? So okay, say I6 is simply called negative 12. Okay, just moving the opposite. So this is minus 12. What about I7? So I7 again, if you notice, is in the opposite direction as 6 amps, right? So I7 is simply negative 6. Okay, those currents are known already. Plus I8. What about I8? I8 is simply, it's coming from V2 going all the way to V1, right? So I8 will be V2 minus V1 divided by the resistor across it is just 2 ohm resistor. And this is equal to 0. Okay, so let us simplify this further. This is V2 over 4 plus V2 minus V1 over 2. Negative 12 minus 6, that is negative 18, right? Oh, this is positive, of course, because of taking the other side of the equation. That is positive 18, right? And then I'm going to do the same thing. I don't like fractions. So I'm apply the whole equation by the common lowest common multiple of 2 and 4 and 1, of course. And that is equal to 4 itself, okay? So 4 by V2 over 4, that is V2. And then V2 minus V1 over 2 by 4, that is 2. V2 minus V1. This is equal to 18 by 4. That is what? That is 72, isn't it? Let me just confirm 18 by 4. Okay. Yes, 72. Great. All right. So now let us simplify this. So if we simplify this, we have V2 my plus 2V2 minus 2V1 equal to 72. And this now becomes what? 3V2 minus 2V1 equal to 72, right? So this is the second equation. So now we have two equations, right? The first equation was this, and then the second equation is 3 V2 minus 2V1 equal to 72. So this is second equation, right? Now we need to solve these two equations. So you can use elimination method. Whichever method you want to use, it's up to you, okay? Please use whichever method you want to use. Now, before we do that, let's arrange them if you want to use elimination, right? I need to start with V1. So I'm going to do this. I'm going to write 8V1 minus 5V2 equal to negative 120. Even for the second equation, I'll start with V1, right? So I have negative 2V1 plus 3V2 equal to 72, right? Now, I told you you can use each other method if I find it comfortable. So I'm going to use elimination where I'm going to get rid of V1. So for me to do that, I'm going to multiply the second equation by what? By 4. Okay, because I want to these coefficients of V1 to be the same, right? So I've chosen the coefficient of V1 to be 8, right? So it means even for the other equation, its coefficient must be equal to 8. Okay, so let us simplify that. So this equation becomes what? This equation becomes negative 8V1 plus 3 by 4, that is the 12V2, right? Equal to what about 72 by 4? 72 by 4, this is equal to 288. So the second equation, if I multiply by by 4, it has become this, right? So now let us now put them together. 8V1 minus 5V2 as the first equation equal to negative 120, and then negative 8V1 plus 12V2 equal to 288 as the second equation. So for me to do the elimination, I need to add them, okay, because this side is negative, the other side is positive, so it means addition is going to work. So if I add these two equations, this and this are going to add up to 0, meaning I've managed to eliminate V1, right? And then negative 5V2 plus 12V2 there. What is negative 5 plus 12? That is 7, right? So I have 7V2 equal to negative 120 plus 288, right? So you're going to add negative 120 plus 288. This is 168, right? Now 168 divided by 7. This is 24, isn't it? So I'm going to divide by 7 here. You divide by 7 here. So our V2 is equal to 24 volts. Okay? Now we can choose any of the equation to solve V for V1, right? So I'm going to choose this equation, 3V2 to solve for V1. I'll choose this one. 3V2 minus 2V1 equal to 72. So let us substitute. V2 is 24, right? Minus 2V1 is equal to 72. What is 3 by 24? 3 by 24 is equal to what? 72 minus 2V1 equal to 72. So you notice that this is negative 2V1 equal to 72 minus 72. I'll take this 72 aside. This has to be equal to 0, right? So you see that V1 is simply equal to 0. So V1 is equal to 0. V2 is equal to 72. Sorry, 24. Now, let's see if this question makes sense. Now, how can you make sense out of this question? So I'm going to erase this whole thing, right? Let me see if it makes sense first. Okay, so we said there is no voltage across this guy, right? V1 is equal to 0. So this is it's a ground. It's more like this guy is a ground now, right? It's equal to 0 volts, right? This is 0 volts, right? So if this is 0 volts, and again this is a ground, 0 volts. So meaning that 5 ohm resistor and 10 ohm resistor are shorted out, isn't it? Because there's no current through them. Oh, no, not precisely shaded out. They're more like okay, so there's yeah, I can you can say that yes, they're shaded out. There's no current through them, isn't it? Okay, they're shaded out, or maybe you can say that open and all that. I don't know. So you see that because if you calculate I1 we said is what? You said is V1 minus 0, right? Over 10, isn't it? That's what we said about I1. And V1 is equal to 0. 0 minus 0 over 10. So I1 is equal to 10 sorry, 0 amps, right? So meaning there's no current flowing through them, right? Okay, they are shorted out from the circuit. And then similarly, I2 is the same thing, right? You said is V1 over 5, right? And V1 is simply 0 over 5. Again, this is 0 amps, right? So meaning that this part of the circuit is not, is dead in short, right? And then what about I3 already we know is 12 amps. What about I4? We said I4 is equal to what? V1 minus V2 divided by what? 2 ohms, right? So I4 is equal to V1 is 0, V2 is 24, divided by 2. This is negative 24, negative 12 amps. So negative 12 amps means what? That the direction you assumed for I4 is wrong, huh? Isn't it? Actually, I4 is moving in the other direction, isn't it? I4 is actually moving in the other direction. This is the actual direction of what? I4. Okay? Let me just write like this. This is the actual direction of I4. So I4 is the same as I8 because this is the direction that we have shown for I8, which is in this direction. So this is actually the true direction. And it's 12 amps, meaning that the current that is moving just the same, this 12 amp given here, because there's no current that goes through this path. So this current comes here like that, 12 amps. And then what about I5? If you notice, what did you say about I5? I5 is equal to what? Okay, I5 is equal to what? Let me just clear this space here. Chill. Okay, we said I5 is equal to, oh, we need to select the whole lot of it. Okay, let me just erase this direct. Okay, we said I5 is equal to what? Let me just erase this direct. So we said I5 is equal to what? V2 over 4 ohms, right? That's what we said. So because V2 minus 0. Okay, so V2 we said 24, which is 6 amps, right? Okay. So what does this mean? It means that this same 6 amps is the same current that is going to flow through this guy. And then it goes back like this, okay? You see, we're getting 6 amps as what? I5. And then I6, we assume it's negative 12, but you know I6 is actually I3, which is in this direction, right? So it's more like now of this circuit. If it, at this point is 0 volts, this is a ground now, okay? And also this is 0 volts, remember, this is a ground. So it means that this resistor here and this resistor here and this kind source here and that kind source here, they're in parallel. So actually this circuit in the actual sense looks like this. We have all those elements in parallel now. Okay, because this part but it's not necessary. Okay, we have already finished the question, so please in case it's say why is it doing this. Okay, I just want to show you that how this thing can make sense, right? The question is done already, so don't have to worry. Okay, again we have what? We have the resistor here, and then we have another 60 amp. All these are connected to the ground, 0 volts. Okay, and then this is 12 amp, this is 6 amp. Here there's a what? This resistor 4 amp there, and then another one for 2 amps this side, right? 2 amps, 4 amps. So this is more like a equivalent circuit because those other 2 resistors have been ignored, isn't it? Okay, those other 2 resistors have been ignored. So this is the equivalent circuit. So we have 12 amps coming like this, and then another 12 amps through what? Through the 2 ohm resistor. This 12 amps. And then you have 6 amps coming in like this, right? Through the 4 ohm resistor, 6 amps as well, right? So notice that the kinds entering and the kinds leaving are the same, right? So we have this kind entering. So these in yellow are kinds that are entering, and then the ones in red are the kinds that are leaving, right? Okay. So the sum of those guys is equal to 0. Okay. So this is the end of this problem. Please, if there is something that you're not clear on, please don't hesitate. Okay. Oh, and by the way, I said my email. I'm going to send my email address. So this is my email address. I'm going to write it. Okay. So in case you want to contact me via email, this is my email address. There's no space there, by the way. Okay, this is 98 at gmail. Okay, .com. This is Stephen. Okay, Stephen, meet, MITI. And then you can send me an message in WhatsApp. Okay. Yeah. So please contact me. And then if you need any help and other, please let me know. Okay, for now, we end our session. Thank you so much for your time and for your patience. Okay.